So again, locate which ones these are. Find your vertex. Find your vertex. These were 0, 0, so therefore they're not going to have anything extra here. This one's opening down. There's the negative sign. This one's opening left. There's your negative sign. This one, find your vertex. Your vertex is 3, 1. So approximately 3, 1. There's your vertex. That vertex, remember, it's like a circle. It comes out the opposite way. On this one, your H always goes with the X. No matter where you put it, your H is always with the X. So negative 3, 1. So negative 3, 1. There's your vertex. Your P is negative, and you didn't really have to worry about what it was, but just if it was positive or negative. It opens down. So far, so good? Okay. Again, get rid of your fractions. Get rid of your fraction. You need your x squared by itself because that's the square. Use a reflexive statement here. Flip them around. Easier to look there. The P, whatever it is going to be positive. So it's opening up. Your vertex is 0, 0. Oh, you had to find everything on these. Okay. So, therefore, set that equal to 4P. Sorry, this one you had to find. Solve for P. Now, remember, P is the distance from the vertex to the focus, and then from the vertex to the directrix line. If this is your 0, 0, rather than worry about the formula, you need to go from this point to this. You're changing your y, right? So take your x, keep it the same, and add 1/2 to your y. There's your focus point. Now, if you use your formula, it's basically the same thing. Take the h and take the k, that should say k, plus p. You're taking the 0 plus p. But try to do this without the formula, though. Your directrix is a line. And right away, start yourself this way. It's a y equal. So if it's a y equal, all you need is the y coordinate. Sound good? Because you actually need the x by itself. In your formula, it's x minus h squared. So whatever the square is, that has to have a 1 in front of it. So we got to get rid of this guy. So just multiply by 2 for the denominator. Got rid of it. Now, to find your directrix line again, start like this. It's going to be y equal. You need the y coordinate. And that's the only one you're changing. So it's down 1/2. So there it is. It's much easier than having to memorize your formula. Because what ends up happening with your p's, when you subtract a negative, it becomes a positive. When you subtract a positive, it stays a negative. So your negatives and positives kind of get in your way. You can pretty much judge this. Axis of symmetry, that's the line that cuts through your parabola that you find your vertex on and you find your focus on. The next one, it was already set up as y squared. The y squared has the 1 in front of it. Negative 6 is equal to 4p. Find your p. So you've got a y squared, which opens left or right. The negative p means it opens toward the negatives. It opens left. Your focus, therefore, I always find if you write your vertex, it's much more helpful. Because now, notice your p is the distance here and here. So you're moving the x. So this side's got to be smaller, doesn't it? So there's your negative 3/2 0. This side's got to be a positive. There's your positive 3/2. And it's a line. It's an x equal that x coordinate. You can absolutely use your formulas. But I think really, if you get used to doing it from the graph, did you guys use your formulas or your graph? Would you find it was easier? Formulas? Graph, formulas, some graphs, some formulas? Okay, keep those formulas handy then. What it is it's a different way to look at your beloved parabolas that you love and put in as quadratics all the time. Again, we did vertex form when we did transformations, and we completed the square. This was way back when, way back in the beginning of the course. So it's kind of a nice way when you look at this format to be able to find all the pieces and know where you're going with it. All right. 65, it's an x squared. X squared has to be by itself. So move 6y over. And if you're having a hard time, set it up to the equation. Make sure it falls in this format. Make sure the square is by itself, equal to 4p and whatever the other one is, whichever one is missing. So now you know that this piece right here is your 4p. You know it's opening up or down. Because the p is negative, it's opening down. You're again at 0, 0. And when you find your focus, you're changing the y only. So the y is going down here, negative 3 halves. So 0, negative 3 halves. H, k plus k. If you do the other one, the directrix, it's a y equals line. It's moved up 3 halves, so y is equal to 3 halves. Remember, the focus is a point. A directrix is a line. Kind of like, you know, when someone says, focus on one thing, one point, and focus on one point, not a line of things, right? Your eye goes to one thing. And they say, just look at that. When you go to the dentist, and you're nervous, and he says, oh, just take a picture. They have all those pictures of clouds and suns and everything else up on the ceiling. It's supposed to make you relax, and they say, focus on something nice up there. And you're supposed to stare at it and make you feel better. So focus is a point, a directrix is a line. Right? 67, you got the x squared, get it by itself. Move this whole thing to the other side. Leave it like this, because this lines up to your formula. Pull out your vertex. Do that first, because that's what's going to help you sketch. Find your p. Your p is negative 2. So if this is my vertex, negative 1, 2, negative 2, and I'm sliding down, I'm only changing my y. So my focus right away is going to start like this. If I'm here at negative 2 and I'm going down 2 more, I'm at negative 4. Make sense? My P says bring me down 2 more. Now the directrix goes in the other direction. So from negative 2, go up 2. Up 2 plus negative 2, that puts me at 0. This is a line, a y equals 0. There's your directrix. If you need to, use your formulas, but try to get it off the graph. Questions? Is there more? Another one? Ready. One more, right? One more. Okay? Now, this x was by itself. Yeah, it has a fraction in it, but that's okay. Now, set this equal to 4p, find your p. It's an x squared, it's going to open up or down. P is positive, it's going to open up. Find your vertex. Your vertex is at negative 1 half, 1. So, use this point. Because you're moving up and down, you're only changing your y. So your focus is going to start with negative 1 half. And whatever your p is, you're going to make it come higher than this. So obviously I must have to add 1 to that. There's my focus. My directrix has to come down, so the y is changing. So I'm moving down 1. So up, y is equal to 0. There's my line. Just find your y on that one. The x stays the same. It's a little bit different to look at these. So you've learned quite a few different formats for your parabolas. If you take this in college, this is the format they will do with your parabolas. they will need you to find a focus and a directrix. This is the format you're going to have to use. So this is good to get this down pat. Questions? I know you have to have questions because a lot of you had blank pages there, or pieces. Aaron, question? No? Everybody's good with this? Key to this is setting up where my x's and my y's need to go. So let's locate which one has the square. Which guy has the square? The y. So we're going to follow your format for y. Your format for y does this. So anything that has a y, you want to get to one side, the left side. Anything else, put to your right side. So this guy I want, and this guy I want. I think the easiest way to do this one is I'm just going to move them that way and then just reflect it, just so that they stay positive. Is that okay with you? We add this to the other side. So we're going to get 4x minus 33, because these guys are coming out, equals y squared plus 2y. Now I'm going to reflect this. I want my y squareds to be on this side. Could I absolutely have moved these guys over and then divided by a -1? Yes. Okay. Now, I only have one side to complete the square, because I only have one square. So remember how we complete the square? We take this guy, we leave ourselves a little space to complete the square. What's nice is, whatever we add to that side, we add to this side. We only have one side to complete the square. So we went to the middle term, and we took half of b. So what's half of 1? I'm sorry, half of 2. 1. So, y plus 1 squared. Now, what is 1 squared? 1. And that goes here. So, we now add these pieces together. We collect the right terms. And you notice we're close. We got the left side where we want it. But the right side, we need to have an x minus something in parentheses. So what can we factor out of that right side? 4. And this is our standard form. So now we can find everything we need to for our parabola. So what's the vertex for this guy? The 8 comes first. Gotcha. 8, -1, right? The h always comes first because the x comes before y, h comes before k. Okay? So we know our vertex. This, if it helps you, put this format underneath it until you start really getting a feel for this. That's how we found your vertex. H is 8, k is -1. Let's find your p. So we're going to say 4p is equal to 4. Therefore, what's p equal to? 1. So now, we know it's a y squared. We know p is positive. Tell me what kind of parabola I have. Where's it going? To the right. It's opening to the right. So I'm going to find my vertex, 8, -1. Remember, you're sketching. And you're going to open to the right. Now, if it helps you, draw an axis of symmetry. If that helps you, your focus has to be on that axis of symmetry. And my focus has to be wrapped around by my parabola. So my focus is here. My directrix is a line on the other side. Remember, that directrix cannot cut through your parabola. So it's got to be on the other side of it. Now, here's the thing. My p is 1. It's 1 unit this way, 1 unit this way. So find me my focus. What's going to change, my x or my y? My x. So it's h plus p if you're doing this. H plus p, comma k. So h is my 8 plus 1 is what? 9. So does that make sense? I moved over 1 unit from 8. Yeah? Now my directrix is 1 back. My directrix is a line. Is this a y equal or an x equal? The y equals. Oh, sorry, wait a minute. Sorry, my directrix is my blue line here. Can't be a y equals. My directrix is my blue line, and x equals. So all I need to do is go back 1, and the y is going to stay the same. I just need to find the x. So what's 1 unit before 8? 7. So I've got my directrix. I've got my focus. I know my vertex. I know my p. And all I have to do is just find an intercept. An intercept is where your parabola is going to cross either the x-axis or the y-axis, or it could cross both. I've got to find this guy. Kind of helps me decide how wide my parabola should be. So when it crosses the x-axis, which one has the 0, the y or the x? The y. So I need to substitute in y equals 0 so I can find this x value. Whichever one you want to use is up to you. I would probably use this one. Use this and substitute the y of 0. And you're going to have to distribute this. And what is 1 squared? 1. So I'm going to add 32 to both sides. And I'm going to get 33 is equal to 4x and divide by 4. So x is equal to 8 and 1/4. It's a pretty wide parabola, isn't it? So my intercept is 8 and 1/4, comma 0. It just tells me like where to put this parabola. It's kind of wide. Now technically it has no y-intercept. If we came here and we put an x for 0, just to show you, just ignore this one down here for a second because I'm going to use this. If I put an x of 0, this would be 4 times a negative 8 is a negative 32. If I took the square root, could I take the square root of a negative number in our real number world? No. Therefore, I have no y-intercepts. So algebraically, I can find this out as well. I have no y-intercepts. And we know that by looking at it, right? We know it didn't cross the y-axis. It's going the opposite way. So we completed the square so that we could find its vertex. We could find p. We could find its focus, its directrix. We did an intercept so that we kind of know how wide it is. If this was at 8 and this is 8 1/4, it's fairly wide, right? If it was at 10, my parabola would be a little more narrow. Good? I'd like to squeeze one more in. Questions on this before I get rid of it? Yes. The 4p is going to help us find our p. It's just part of your standardized equations. The p is the distance from the focus minus vertex is p. It is the distance to the focus. Distance is always positive, so p could be negative, but your distance is I use the distance part rather than the formula part. So I find the distance from my focus to my vertex, and I use the points to help me get there. You have a formula for it too. So whatever p is, if p is positive and it's an x squared, it's going to open up. If it's an x squared and it's negative, it's going to open down. That's what we use the positive and negative for. But the distance between the focus and the vertex is your measurement of P. Yeah. Okay? Let's hit one more, because this has a fraction in here. So, since I need to get that x squared all by itself, I need to get rid of that fraction. What can I multiply both sides by? 6, or, if I want to get rid of that negative at the same time, I'll multiply by negative 6. Will be pretty tricky. So, negative 6y, this negative 6 makes this disappear. I need to get, it's an x squared, so I'm just going to do a reflection right now and put the x squared on the side. And I need to get the x's by itself. So I need to add 2 to both sides. That's not going to help me complete my square until I move it over. Leave a space to complete your square. And because I add to one side, I have to add to the other side. So what's half of 4? 2. What's 2 squared? 4 on both sides. So, combine this. What's 2 plus 4? 6. Now, this has to align up to this. I need that 1 minus k thing in parentheses, so I gotta have y be 1. So what can I factor out? A negative 6, I need y to be 1. Okay, I have my equation. What is my parabola? Describe my parabola to me. Open up or down, left or right. Down. It's an x squared, so it can go up or down. It's negative, so it's opening down. What's my vertex? Negative 2, 1. Good. 4p is equal to negative 6. So p is equal to negative 3/2. So here's where we start. Negative 2, 1. You told me it's opening down. Look, this time you might have all those intercepts. You'll have 2 x's, and you'll see that when you take the square root, and you'll have a y. So here's my vertex. Now, he says, go down here. So if I'm on this guide, what's going to change, the x or the y, when I go up and down? The y. So when I find my focus, notice this is 1.5, right? I go down 1.5, this is 1. It puts me slightly below here. So negative 2. If I add these together, it gives me negative 1/2. There's my focus. And my directrix is a line. Is this going to be a y equals or an x equals? Y equals, and take 1 and add 1.5. So it's going to be 2.5, or 5/2. Okay, and your intercepts are going to be x equals 0 and then y equals 0. You add the p to the y, so if I add 1 plus a negative 1.5, I get a negative 1/2. All right. So y equals, because I'm adding the 1.5 up that way, I'm actually subtracting the negative. It's actually subtracting the negative, which makes it a positive. Which is why I'm kind of like, would rather see you use the